Continuing our discussion about Gantt charts, it's important to use these or this scheduling approach to plan activities, make sure that they are planned, that they are documented and that they're functioning properly. Also, it allows managers to estimate or schedule and see how long these particular activities would take. Thus, giving them an idea of the overall project and how that will be developed. Okay, and so Gantt charts are something that you would expect to see in particular projects that you may be involved. And so here's an example. Delta Airlines, whenever they have layovers, they have a particular Gantt chart that they utilize when dealing with layovers. And so it will depict all the activities, the layer one activities, right, which are the major categories of activities, then the subcategories, ultimately the individual activities. So this will allow them to be able to complete that project in the timely manner. And so managers will be able to identify any particular issue during these exercises, during these projects, and be able to address that accordingly. However, Gantt charts have a little limitation. They do not allow us to see how the activities relate to one another. And for the purposes of doing that type of exercises, then we would want to be able to use other tools that can show us the relationship between one particular activity and the other. So why do we go about doing this type of scheduling? Why do we schedule? Well, we want to be able to see if there's any relationship between one activity and other activities and how they relate to the whole project. Okay, that's an important thing or a reason why we would want to do scheduling. The other thing is to detect if there's something that precedes the particular activity. Maybe the activity that we're involved in has an impact on a future activity. And so the other activity cannot happen before we have completed this particular activity. It also allows us to look at the time that we're going to spend, the resources that we're going to use, the cost associated with the activities. And so having an idea of all these activities and how they are going to be addressed, that gives us an idea of how we're going to incorporate that in our budget analysis, how we're going to incorporate that in our costing to be able to control that the activities as they are being carried out, they do not spend more resources than what they should. It also helps us to manage people better. And so it's important then for us to be able to use these type of tools that we have to our disposal to schedule activities, to schedule various deliverables for the project. And so the Gantt chart is a useful tool. However, it has, like I said, many limitations. It doesn't allow us to see how one activity relates to the other. For that, we have the PERT and the CPM tools. The PERT is the Program Evaluation and Review Technique, and the CPM, the Critical Path Method. Both techniques were developed in the 50s, and they do allow us to see how one activity relates to the other, and it allows us to see whether they may have an impact on the other. Okay, and so the PERT has 3 distinct time series or time estimates, and these time estimates can be pessimistic, can be optimistic, and most likely. Those are the 3 estimates of time for the activities. And the CPM, well, that uses only one estimate of time. And so we're able to see to some certainty, to some level of degree, that we will be able to complete the activities in a specific order and a specific time that will be allocated to the project. So how do we go about developing these? Well, first, we said we have to define yes, the project and prepare the work breakdown structure, which we already have done in the planning phase, right? We have already done this, and we follow these 6 steps that we're going to look at right now. Either if we use the PERT framework or if we use the CPM framework, we have to follow these, right? Preparation is important. Then we have to define what is the relationship between each of these activities to one another. Is one activity preceding other activities? Then we need to look at that and define that there. Then we're going to draw the network connecting all of these activities. And we will see 2 types of networks that we want to draw: the activity on node and the activity on arrow. We will see those examples in a second. We're also going to look at how we can assign time and cost estimates to these activities. That's important. That's one step also, or the 4th step actually of using the PERT and CPM framework. Then we're going to calculate what's the critical path. Okay, and the critical path is computing the longest time path through the network. And so it is a path that will take the longest or be the longest path, but takes the least time to complete. We will also then use these tools, the CPM and the PERT tool, in controlling and making sure that we are completing on time and that none of our activities are causing delays. So let's look at both the activity on node and the activity on arrow path. To do that, let's say we have several activities. And so each of these activities are represented by the letters A, B, and C. That's 3 activities. So we have activity A, okay? And when it comes to drawing an activity on node, we draw the node in a circle and we put the activity inside the circle. So we have activity A, and then we have activity B and activity C. And so how do we go about connecting these? Well, we connect these with simple arrows. And so this activity on node network tells us that activity A precedes activity B, and activity B precedes activity C. We cannot start activity C when activity A ends. We have to wait for activity B to end. So it follows these activities, or each one of them has their own precedence, and that's how they are related. So this is a simple activity on node network with these 3 activities. Let's say activity C depended on activity A and activity B finishing at the same time. So we would have activity A, activity B, and activity C. And so we interconnect both activity A and B to C. Okay, so we would draw an arrow from A to C, an arrow from B to C. So one thing that we can mention here, whenever we're drawing these activity on node networks, or the one that I'm going to present in a second, activity on arrow networks, that we draw straight lines whenever drawing our arrows, okay? So that it is clear and it can be understood very good. Let's draw another one. In this time, we have a node that precedes 2 other activities, or an activity that precedes 2 other activities. So we would have, say for example, activity A this example, let's say activity A precedes activity B and activity C. So we would have an arrow going from activity A to B and from activity A to C. That way we show that there is some relationship between these nodes, depending on how the arrow or where the arrow begins and where it ends. We can then draw an activity map or activity on node network in that case. So if you follow in your textbook, you can find this activity. It's going to be table 3.1, okay? Table 3.1, let me share it here briefly so you can take a look. So we see a series of activities or a table presenting several activities with their description and immediate predecessors. And so in this activity, or in this table, tells us that activity A and B, building internal components and modify roof and floor, they do not have any immediate predecessor. But activity C is follows activity C, right? And activity D follows activities A and B, while activity E follows activity C. Activity F follows activity C as well, okay, and so forth. So let me go ahead and draw this so you can see, okay? I'm going to put the diagram, hopefully, beside the video. So we have activity A. Nothing precedes activity A. Nothing precedes activity A. And we have activity B. Nothing precedes that activity either. We have both of these activities, and we have now activity C that follows activity A. We have activity C, and we have, let's draw the arrow one time, activity A to C. Let's look at activity D. Activity D is follows activity A and B. So we have activity D. And so we draw the line or the arrow from activity B to activity D, from activity A to activity D. Again, we're drawing an activity on node network here. Let's look at activity E. Activity E follows activity C. Let's look at activity F. Activity F follows activity C. We have activity G that is follows activity D and E. We have G here. And finally, we have activity H that follows activity F and G. So there you have it. That would have been the activity on node network for these set of activities that we see here. We could also draw the activity on arrow network, which is what we will introduce now. So just remember how we can draw the activity on node here, and we will look at how we can draw the activity on arrow. So as the name implies, activity on arrow network, the activities are depicted on top of the arrows. So we have in the simplified version where we only have 3 activities and they are or each one of them follows one another in a sequence. Let's draw these circles. So we have activity A, activity B, and activity C. Okay, and so you notice here that we have the activity on top of the arrow. And what these circles mean now, not a node, but it means that this is the start of activity A. This is the end of activity A, and also the start of activity B, which is the arrow here. That's activity B, and this is the end of activity B and the start of activity C, which is depicted by the arrow, and this marks the end of activity C. Let's say we have activity A and B as the predecessor of activity C. So we have, again, we need to draw the starting point of the activity. The activities themselves and the end point of the activities. So this is an activity on arrow, which tells us that this is the start of activity A and the end of activity A, the start of activity B and the end of activity B, which marks the start of activity C. Of course, activity C would have its end as well. So start of activity C, end of activity C. And that is the activity on arrow network here that we have drawn. Let's go ahead and try the same example that we're looking at, example 3.1, and see how we can draw that activity using the activity on arrow network. So we have activity A and activity B, which don't have any immediate predecessor. We have activity A and activity B there without a predecessor, okay? And we have also activity C, okay? So we have activity C. Let me go back to my table here, okay? Activity C is preceded or precedes activity A. Okay, activity C. And activity D precedes activity A and B. Okay, so we have activity D. Again, remember, this is the start and this is the end for activity D. But because it is preceded, right, by activity B and also activity A, we need to draw a dummy connector there, okay? And so the dummy connector is a dotted arrow going up, going down from the end of activity A, marking that activity D cannot start before activity B is complete or activity A is complete. Activity D then can start only if activity A and B are complete. Let's look at activity E. Activity E can start immediately after completing activity C. So we have the arrow. This marks the beginning of activity E. Okay. And activity F also needs to finish or start, sorry, after completing activity C. So we can go F. See? Okay. Let's put it here. This would be F. Okay. And we have activity G that has D and E as its predecessors. That would be G, F. That would be G. But because E also precedes this, we need to connect this one with a solid line. Okay. And we have activity H, which is preceded by activities F and G. So we have F and G. F and G precede that activity, H. So that is an activity on network diagram. Next, we'll be talking about how we can determine the project schedule, okay? Using the earliest start, earliest finish, the latest start, and latest finish. And in doing this, we will then be able to identify how long it will take and also the critical path method for the entire project.